Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, manim, the famous animation engine behind the 3 blue 1 brown math videos. This powerful Python library lets you programmatically create beautiful and precise animations for explaining complex technical concepts. We'll explore how you can use it to turn code into captivating visual explanations. How does a complex mathematical concept, like a Fourier series, go from an abstract equation to a captivating, intuitive animation? For millions of people, the answer is found in the visual language of the YouTube channel 3 Blue 1 Brown. The engine that drives those famous visuals is a project called manim, and it's where code becomes mathematical poetry. So, what exactly is manim? It's an animation engine built with Python, specifically designed for creating precise, code-driven explanations of mathematical ideas. It began as the personal project of Grant Sanderson, the creator of 3 Blue 1 Brown. The project's influence is undeniable. It has amassed nearly 90,000 stars on GitHub, with over 380 added in just one day. That kind of traction signals a real need for better tools in technical communication. The core problem manim solves is the immense difficulty of animating abstract concepts. Think about the alternatives. Traditional animation software is visually driven, but it often lacks the precision needed for mathematical accuracy. On the other hand, writing graphics code from scratch is just too complex for most educators and researchers. Most solutions were a difficult compromise between ease of use and precision. This is where manim's unique angle comes in. It provides a high-level, declarative framework. This allows creators to describe the what of an animation using Python code, while leaving the how of rendering complex transformations to the engine. This code-first approach guarantees both reproducibility and perfect accuracy. Diving into the technicals, manim's architecture is built on that declarative philosophy. Creators define scenes by simply specifying the initial and final states of objects. The engine then handles the complex work of interpolating between them. At the very heart of this system is the mobject, which stands for mathematical object. Every shape, line, or formula is an mobject. It's not represented by pixels, but as a collection of vectorized points and curves stored in NumPy arrays. A good way to think of it is as a digital blueprint rather than a static photograph, which allows for infinite scaling without any loss of quality. So, when an animation command is given, like transforming a square into a circle, the engine performs a clever sequence. It first ensures both objects have a matching number of points. Then, it smoothly moves each point from its starting position to its final one over a set duration. This movement is governed by rate functions, which control the animation's pacing to create that signature, fluid motion. On top of all that, manim is deeply integrated with LaTeX, the standard for scientific typesetting. This allows it to render crisp, publication-quality mathematical formulas right inside the animation. This combination of vectorized objects and programmatic control is manim's technical cornerstone. So, who is using manim in the real world? Its primary users are STEM educators in fields like mathematics, physics, and computer science. They use it to create video lessons and detailed explainers. Researchers also use it to generate dynamic visualizations for academic talks and papers. And beyond academia, it's even found a home with creative coders who are exploring generative art. But there is a catch. The barrier to entry is significant. Getting started requires more than just Python skills. It also demands the manual installation of system-level dependencies like FFmpeg for video rendering and LaTeX for formulas. This steep learning curve currently limits its adoption to a more technically inclined audience. For all its brilliance, the project's biggest challenge today is fragmentation. The official README file explicitly points new users to a fork called manim community, which is described as more stable, beginner-friendly, and more actively developed. This split creates a lot of confusion and risks, leaving the original 3 Blue 1 Brown version, known as manimGL, with slower updates and potential maintenance issues down the line. This really goes back to its origins as a personal tool. Its design often prioritizes the unique effects needed for specific videos over general-purpose stability. It also appears to lack the kind of robust, automated testing that is common in larger open-source projects. In the end, manim is far more than an animation library. It's a powerful medium for mathematical storytelling. It works by translating the pure logic of code into the visual intuition of motion, and in doing so, it empowers a new generation of educators and creators to make the abstract tangible and the complex comprehensible.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.